In the previous video, we looked at the char and also the Boolean data type, which was the 7th and 8th data types that we've covered so far in the course. It's now time to have a bit of a recap on where we're at with those data types and to also discuss a very important 9th data type that you're probably going to be working with quite a bit in your Java programming. So the 8 data types that we've covered to date are as follows in order. So we have byte, short, int, long, float, double, char, and Boolean. So these 8 data types are actually what's called primitive types in Java. Now when I say primitive type, that's actually something that's defined by the Java language and is named by a special reserved keyword as you've seen. For example, the keyword byte, short, int, long, so on and so forth. So each of these primitive types, as you've found out, as you've seen, has its own style and it's used for different purposes. The byte, as we found out, can only hold a number in the range of -128 to +127. And as another example, the Boolean can be true or false only. As you get more experienced in Java, you'll learn to use the right primitive type data type for a given computing problem. And that's actually all part of becoming a programmer. And I'm going to be teaching that as we go through this course. So again, just to reinforce, those 8 data types we've looked at are primitive types in Java and are built into the language. As we go further through the course, you'll find that there's a way to create your own data types, also known as objects. The interesting thing about doing that in the future is you can actually combine data types. For example, you can create sort of like a super data type that contains maybe a byte, an integer, and a double. But we're going to be talking more about that in future because we're really getting into the concepts of creating classes, and that's actually an entire section of the course in its own right just to do that. For now, it's enough to know that these are the 8 basic types that are built into Java and that there is the ability for you to create your own as we go further into the course. And just to be clear before we continue any further, I did create a new project you can see on the screen. It's called Strings. We've created a number of projects each time, so I'm going to assume you're pretty familiar now with the process of creating a new project. So just call it Strings, and the package name as normal can be whatever you like. So they are the 8 primitive types built into Java, but there is actually a special 9th type that whilst you can't say that it's a primitive type, it's actually something that's going to be used so commonly and it's been so integrated into the language, it really comes across as the 9th data type. So I'm talking about something called a string. So firstly, what is a string? Well, a string is a sequence of characters. In the case of the char, as you saw, that could contain just one character, and the char could also contain a Unicode character, as we showed. Well, a string can contain a sequence of characters, so any number, a much larger number of characters than the char, which of course is limited to 1. So to define one, it's a simple case. Just type string, my string equals, this is a string. So we're using double quotes this time. Remember with the char, we used a single quote around the character that we wanted. In this case with a string, we used the double quote around the sequence of characters that we want to represent as a string. And just to ensure that that's printing out, we can actually just print it out to the console. My string, like so. And incidentally, another way of running it, if you don't want to right click all the time like I've been doing, you can just come up here and click on the green arrow and that will run it as well. And I'll just put that over a little bit so there's a bit more space there and we can see things a bit more clearly. And you can see that my string is equal to this as a string. But we could also append to that string automatically by using the plus operator. So what we can do is we can put something like my string equals my string plus, and this is more. So what that's doing, that's going to append this text in this double quote to what my string really is. Because what we're saying is make my string equal to whatever it currently is when the program gets to this point. So my string currently is set to this as a string, and then plus to add this text on the end of it. So sort of to append it to the string. And if we just do a copy, and we'll print that out again, and we'll run it again. You can see the first time it's still showing the first print output, which is my string is equal to this is a string. The second time it's my string is equal to this is a string, comma, and this is more. So it's added that to the end of the string. So there are other ways to add 2 strings. You can put something like my string equals my string plus, put a space there, then we'll put a slash or backslash u00a9. You remember that from the previous video. That was the copyright sign, it should be. So if we do that, and do another print, we'll run that. My string is equal to, this is a string, comma, and this is more, full stop. And the copyright symbol, as you can see there, 2015. So that's just appended it using Unicode characters. So you can do that as well. But let's try something different. Let's type a new string. We'll create a new string called number string. And we can put a number in the double quotes. And what we're going to do is we're going to add something to it. Number string equals number string plus 49.95. So my question to you is, what will happen there? Will this automatically, because they're numbers, will it add up and say 250.55 plus 49.95? That would equal 300, normally if my math is correct. So what will happen in this scenario? If we go to print this out, the result is number string. So what's going to happen to that? Do you think the answer is going to be 300? Well, let's run it and just see what the answer is, what it actually comes back with. And can you see up here what it's done? So it's taken the first value, 250 and a dot 55, then it's looked at the next bit and added 49.95 on it. However, it hasn't treated it like a number, it's treated it as text only, so it hasn't done any calculations on it. And the reason it hasn't done any calculations is we haven't used a data type that supports numeric operations. So in other words, we haven't used one of the primitive types like a short, an integer, a float, a double, and so on, that actually allows you to add numbers together. In this case, because we've specified the data type to be a string, we're dealing with textual data only, and we're not dealing with anything of a numeric capability. So in other words, it won't do those numeric calculations. Later in the course, I'll show you how you can convert what you think is a number from a string to a number. But as far as the default operations for a string are, it's going to treat something as a string every time. So let's now look at another example. String, we'll call this one last string. Here's another example. And let's actually create an integer called myInt. We'll make that 50. So what do you think is going to happen if we put last string equals last string plus myInt? Well, it turns out that that's valid Java code because we haven't got an error there. So something's happened. So what do you think is going to happen when we go to print this out? Let's run it and see what it comes back with. So what's happened there is we had last string was set to 10. Integer, which is a number, was set to 50. But in this line here where we've added my integer to the string, because we're using a string on the left-hand side and there's an integer on the right-hand side, so what's happened here is we've started off with a string. We've defined a string and we know that a string isn't manipulated like a number in any way, shape or form. It can be alphanumeric, it can be letters or numbers or Unicode characters or whatever. So it isn't treated like a number. But if we then go to try and add a number to that, Java is actually smart enough to say, okay, I know the int that you've defined called myInt is an integer, but I also know that you're trying to add it to a string. So what Java does, it actually converts, or effectively looks at the contents of my integer and converts that into a string to add to the end. So as you can see, what happened was it appended the number 50 to the end of the first part, which was the number 10. So consequently, we've got still a string. It just happens to contain the numbers 10, 50, but it isn't a number in the true sense. It's treated purely as text by the computer. And that holds true for other data types as well. So we could do a double number equals 120.47. And we can put last string equals last string plus double number. We're going to print out You probably can guess what's going to happen here. Let's run it and see. And as expected, it added this bit here, the 120.47. Again, it got converted to text and got added into the string as text. Now, this is only a very elementary way of dealing with strings and adding to strings. In later lessons, we're going to go through this and look at some more of the advanced features of a string, because we can do all sorts of things. We can delete characters out of it. We can append characters which you've seen. We can insert characters at specific positions. There's lots of flexibility with strings, but we need to know a little bit more about classes before we can get into that in too much detail. Just want to make it clear that what I'm showing you today, this plus, something along these lines, you wouldn't normally do something like that in your programming. You'd use other functions to make it a bit more clear what you're trying to achieve. But at this stage, we just wanted an introduction to the string class, and that's where we've started. And just to make that a little bit clear, we know that the 8 data types that we've explored prior to the string were primitive types. The 9th one, even though it looks like it's the same. It's got its own keyword, and it's got an assignment, and it's got a literal that you can add to the right hand side. It's actually not a primitive type. It's actually called a class, and it's treated differently. But the Java syntax for this they've made it easy for us to use a string class. So from your point of view, you'll be able to treat it more or less as a 9th primitive type. So the bottom line here is strings are extremely powerful, and we're going to be using a lot of strings as we progress through the course. That's it. So hopefully now you've got a good understanding of what a primitive type is. You now understand the string class and how, even though it's not a primitive type, you can more or less treat it as one when you're using one. So in the next video, we're going to start talking about operators. Now you've already seen some operators, but perhaps you didn't realize that was what they were called. Operators are these things here. And some of the operators you've seen already are the plus, divided by, multiplication. That's just a couple that you've seen. So, and they actually deal with primitive types, and as you saw with the string class, and they're used much as you'd think they would be used. For example, in the case of a long, we can use the plus operator to add 2 long values together. We're going to go through because there's also some extra operators that perhaps you aren't aware of, but we'll be talking more about operators in detail in the next lesson.